Before the start of the tutorial, I wanted to show that any of the custom HDAs that I am going to use inside this tutorial, you can get them for free from the description, from the link from the description. It should point to the GitHub repository. You can download it, and there's going to be these HDA files inside there. So it's just basically just a Houdini package that you can get all of the HDAs that I'm using inside the tutorial. And yeah, give me a like in this package. And yeah, so one thing I have to notice that this is actually this is going to be Houdini in the HDA file. So these if you're using like a Core or FX Unreal, Houdini is actually going to boot you to the in the license. So that's one of the drawbacks. So but these HDAs are basically opened, and you can basically recreate them if you want to, if you're using like a Core or FX Houdini. So yeah, so let's get started with the tutorial. In this tutorial, I will create a simple setup for scattering props around environment inside Unreal Engine using Houdini engine. So at the end of it, we should have this simple setup where we are bringing a simple Houdini digital asset, and once it cooks, any of the point information that's inside this digital asset is going to be populated by the static meshes that are already imported inside Unreal Engine. So only thing that we are actually sending to this to the Unreal Engine is actually the point data. So in Houdini it would look something like this. So this is my test data digital asset. I could just merge some points. So basically this information is the only thing that we are getting sending to the Unreal, and all the geometry is actually already set up inside Unreal. So let's get to it. So first of all, we want to make sure that none of these assets actually intersect. So we have to somehow get this information inside inside Houdini. So this is where my couple of digital assets is going to come to help us with it. So what I want to do is, first of all, go ahead and export all the geometry that we could possibly use as a collision geometry to check collision inside the Houdini. So what I'm going to do is actually show how we can do it. So I'm using couple of asset packs inside here. So these are great because all the geometry is already set up, all the materials are already set up, and we just have to get this information to the Houdini, delete the meshes that we do not want, and get the send it back in. So we are not going to through digital assets export any import any geometry. Geometry is already inside Unreal Engine from the asset packs. So one asset pack that I am using is actually the Safe House asset pack. There's very awesome high quality assets inside here. So this is one, and there's a couple more, but if you just get some other assets with static meshes, and you want to go ahead and export all of these. So what you can do is, any of the asset packs that you have, just basically shift click, select all of them, and go to the asset action and export, bulk export. This is going to give you option for you to where do you want to store all of these assets. So what I'm going to do is go ahead and go to my cache drive I have set up. They're basically at the Unreal Asset Export, and I have already exported all of these assets in one of these folders. So this will be Safe House, basically the Safe House folder. This is basically where my assets are. So I'm not going to export them right now. I'm just going to cancel. But with these options, it's still going to show me the options. Basically, I deselected everything inside here, except for the export local time, which I probably don't even need it anymore. So basically nothing. I just want to get geometry out of Unreal Engine as an FBX, because right now I just called it out once you have exported it, because right now these are basically U assets inside your inside the Unreal folder, and we can't really import this information easily inside Houdini. But once you have exported them, we can easily access it inside Houdini. so as an FBX files. So let's go to the Houdini to take a look at the export to the setup. So first of all, there's going to be a couple of digital assets that I'm going to, you can go ahead and check them out. So first of all, it's going to be find file inside in folder. So this is digital assets going to basically scan any folder that you're going to give it to, and it's going to scan for the name of those assets. And the name of the assets with these exported is actually going to be Houdini Unreal path. So inside Unreal, what you can do is on any asset, you can go ahead and copy the reference of this geometry file, and it's going to actually give us the path of this asset inside our project folder. So I'm going to go ahead, let's say for this floppy disk, let's actually go ahead and let's say this telephone. I'm just going to go ahead and copy the reference of it. And let's say I want to get this, I want to check anything that I'm going to check for the collisions inside Houdini for this telephone. So what I want to do is make sure that I have this asset inside Houdini. So with this digital asset I created, you can easily do this. So I'm going to, let's actually, let's create a new digital asset. So find file in folder. So what you do is basically give it a string reference. I just copied it and just going to paste it. You can see it's basically a path in Unreal to this asset like that. Now I want to give it the folder path, and I'm going to give it the folder path of my Unreal asset exports, the path where I basically exported all of my assets like that. The file extensions, so FBX, and make sure that you go with the uppercase and lowercase. So basically this is going to be, if you do not specify the extension, and that this, let's say this file would be like an OBJ file, it wouldn't find it. So make sure that you put in the extension that this asset is inside. So this is going to FBX, and we can basically just, with this one, you can press reload files. You can see it has found automatically our asset, and there's a couple of more options for us. First of all, there's going to be a uniform scale because the Unreal is actually working on the hundreds. So we have to, and the basically the scale is 1 to 100. So that means we have to actually go ahead and scale this geometry by 100 times. Basically it has to be smaller. So this is why I actually gave the uniform scale options for us. You can see that if I scale it to 1, you can see that my telephone is right now like 25 meter large. So by default it's going to be 0.01 with the intentions for you to use this with the Unreal Engine. But you do not actually have to use it just by Unreal Engine, because let's say I have this same path inside here. Actually, I did some custom exports. The rubber toy from the base of from the Houdini. I actually went ahead and exported it also as an FBX file. And let's say, let's say I want to get this file. I just can go ahead and rename it. Just copy the name of it. And let's say I want to paste inside here like that. And let's say I want to also get this rubber toy, and inside here I go ahead and press the reload files. It should also find it. So you can see it's very small inside here because we are let's align and distribute like that by piece attribute. That's going to be a name. You can see my rubber toy is also found. So it doesn't have to be strictly Unreal asset file location path, but inside here we're actually going to use it like that because I want to check for collisions and apply this path as an attribute inside for this geometry. So other options for our assets is so here is basically set a file name. So by default, these FBX that are actually exported from the Unreal Engine should also already have name of it, which is basically the same name as a static mesh reference, basically SM phone, like that. This should be the name of the name attribute inside here. But let's say you do not have it, you can actually go ahead and also set the file name. So its name, so this would override the name. Let's say I write name 2, and you can see that there's basically, we have asset right now also name 2, which is the name of it. So inside here we do not actually have to use it, so let's deselect that. And one important thing is that we want to set the Unreal instance attribute. So basically, if it has detected that this is the Unreal path, it's going to automatically give you options for us to set up Unreal instance attribute. So this is going to be a primitive attribute with the path of this, basically with the path of this asset inside our Unreal project. So this is very important for us to use, and for us, for our points that we're going to export to the Unreal, to pick this asset inside our Unreal project. So this is very important. If you have it, you can use it like that. So at this point we have gotten our assets. So inside here, basically the shelf example that I showed inside here, where I have scattered all of these assets. I started by adding a point, and I wanted to basically get shelf. So this is basically the setup for our find folder, basically getting all the assets that we have exported with this setup. And yeah, so there's maybe a couple of more options for us to select, but that's going to be a little bit later. There's also going to be option for us to use a JSON file. So, but for now, let's just go ahead and continue with this setup. So we have this. Now I want to get some collision detection for our asset. So what I do is basically go ahead and create a group. And my group is going to basically be the surface that we want to scatter our props around. So I just manually selected both of these, then I blasted them. I went ahead and poly extruded something like this. So this is basically going to be my boundaries that I'm going to check, so that my assets do not scatter, like go over the shelf edge like that. Then I just go ahead and merge it together. And then I'm going to use the attribute from pieces, basically attribute from pieces geometry file. So this geometry node. So this node is going to take our points that we just created, and then for the shelf, I have just one point. I give my up and normal attributes, which is going to be the way that we can control the orientation of the copy geometry. So, but for this we don't really need it. And inside here, this normal we actually don't need, so that's for later. Basically, just want to give this point the attribute of our Unreal instance of this geometry. So by default, it's going to give ahead to basically give a random. Since we have only one point inside here, it's just always going to give our Unreal instance attribute to this one point that we have inside here. So this is important for us to have basically just a single point, and we can look at it, how it looks inside by copy to points. So let's say we have like a grid, something like maybe like this. Let's say we basically just want to take a look how it looks like inside here, and we do not export this to Unreal. We're just going to export the points of it like that. So, but for this you're going to want one point like that. So this copy to points is good reference for us to see how it would actually look. So this normal is basically once we are starting to copy to points, it's actually going to start to look at the point normals. Let's say I want to rotate my shelf. I just go ahead and rotate my normal inside here. So now my shelf would be, let's say, rotated around like that, say 90 degrees. And now that we have our base geometry, what we want to do is scatter some points around the around the planes that we actually want to populate with. So just go ahead, and then I just went ahead and blasted everything but the surface that I want to scatter to. Then I put down a scatter node. So something like a 3000 is pretty good amount inside here. So in attribute triangle, again, I set up my up and normal vectors, because I want to make sure that my props are actually going to be rotated randomly around the around its normal. So this is where my attribute adjust vector comes. So if you take a look at this, so let's go on top of it. So let me just zoom in. So I'm going to visualize my attribute, so my normal. So you can see all of my normals I set up that it looks at the positive x-axis like that. And after my attribute adjust vector, I have created it basically that we are rotating on the axis of rotation going to be y-axis, which is basically up, and that I'm actually rotating my normal around 90 degrees integrals. So this means that any of the props can be rotated in either 0, 90, 270 or 180 degrees like that. And that's good, because that's where our copy to points is going to look at this normal attribute. It's going to go ahead and copy randomly, going to orient our props like that. So this is, so inside here I have basically again got my props that I want to scatter on my shelves. This is just a big list of the Unreal paths that I want to scatter around like that. In the setup is basically the same. And this is the copy to points intersect analysis node that you can go ahead and download. You can see it's going to go ahead and run around a little bit. You can see at the end of it, we should have something like this. Basically, it's inside it. It's basically takes our input geometry. So let me just go through this. So first input is my point cloud, which is just a points that you want to scatter to. The second one is additional collision geometry, which is basically the geometry that we just created inside here. And the third one is the copy geometry, which is going to be this that we just went ahead and created. And this and want to make sure that these points have the random attributes. Basically, these points should have this geometry's Unreal instance attribute on it. So you can see that we have this Unreal instance path, and this is actually the attribute. So you're going to scatter randomly assign this attribute to our points inside here. So put down attribute from pieces node. Inside here, you make sure that the piece attribute is its Unreal instance, and you can see that after that we have randomly assigned these attribute to all of our 3000 points like that. In this copy to points, we're going to use this attribute, a piece primitive attribute, which is the Unreal instance, that's going to copy basically matching points. Basically any point that have this attribute is going to be copied this geometry. So that's kind of how copy to points works inside Houdini. So make sure that you have this, separate all the geometry, and once you have done it, you can just go ahead and do this. Let's say you want to a different seed, press on it, it's going to think about it. You can see it basically goes around, and it goes a lot faster. At the end of it, you can see every time you're going to get a different seed where they are scattered. And there's a couple of cool things that you can do. There's a cycle mode. I actually like the patches mode, which is basically going to create the clusters around the where there are going to be same kind of assets around. If I put down clusters, you can see that now I kind of have there's like a boxes, and these containers kind of like less randomized look of it. So, but you can basically do any of this. Just going to put down back to the random like that. Let it think about. You can see how fast it goes like that. So after that, so by default, this always going to basically show the copy to points, but inside this asset there's just a simple copy to points node that is going to just always show that you can see the results as an instance geometry, but this is not the output that you want to actually send to the Unreal Engine. You want to send out the point cloud information, which is the second input. So we just want to send these points to the Unreal Engine because all the geometry is already inside the inside Unreal, and it's going to just look at these normals and our normals and up vector to determine the orientation of our prop, and the Unreal Instance attribute to take a look at which prop we actually should which prop to actually take from the project, from the projects like that. So yeah, so we have now copied the points. Now we can, what you can do is basically just go ahead and merge both of these, basically the shelf, which is the single point, and the instance shelf contents like that. We can merge them together, and another custom HDA is going to be instance point post process. So in this node, we can actually go ahead and do a little bit of a post process for our points, as the name would suggest. So what I have to do is, there's a couple of things. So first of all, I have this attribute name, which is basically we want to feed our point data from our merged node as a point cloud, and all of our geometry that we are actually using inside this point cloud as a second input, so that we can actually visualize what we are actually doing. So this is going to be basically just a simple object merge where we are merging together both of these find file in folder nodes inside here and inside here. What you can do is go ahead and give the attribute name, which is going to be our Unreal Instance, and visualize a piece attribute, which is used for copy to points, is going to be the same attribute, so that we can get the correct copy to points geometry visualized. So, but the cool thing is inside here, what you can do is actually go ahead and we can press this fetch unique values. So this we will clear this out. Let's say press fetch unique values. It's going to look at this attribute name Unreal Instance and get all the unique values that we have for it, which is basically all of these names for our meshes. It's going to tell also how many of them we have. So what's cool about this, we can make sure that, let's say we want to make sure that we have only one instance of all of these. Let's make this all to one entry. You can see it's going to basically just randomly go ahead and delete all of the, basically just leave one of them. And what you can do is basically also go ahead and change the seed of it. So this is going to it's just a simple sort node inside here that's going to shuffle around the point with point numbers, and it's going to determine which actually we are going to go ahead and delete. What's cool about this, that we actually, let's say I want to make sure that my assets are actually going to be, let's reset it. Let's say I want to make sure that all of my assets are going to be more on the z-axis. We can actually go ahead and sort the points by the z value, and let's say I now make all of them at 1. You can see it's basically going to try to find all of the assets. Basically it's going to leave the assets that are more on the, basically from the negative z to the z. You can see that assets that it can actually save is going to be more on the z-axis like that. Then we can reverse it. You can see now they are actually on this opposite side like that. Let's say I want to get more assets, maybe like these, like that. You see now my shelf is more filled on the positive z-axis, and it's a little bit emptier on the negative z. And what's cool about this, since these names are basically just names of the basically the instance attribute, we can actually use the name attribute that we have actually preserved. So let's take a look at it. So we have on these points the name attribute. So we actually do not. So what we do is make sure that, let's say we want to easier reading of these unique names, what we can do is go ahead and read by the name attribute. Since for these assets it's going to be basically the same, since the names, all of the names are actually for the assets are actually unique, we can use the name attribute for us to fill these unique parameters. So let's go ahead and make sure that we actually have our name attributes, that we actually go ahead and preserve our name attribute. So this would be actually happen inside. So let's start by looking at our find folder now. So this should be a primitive attribute that is name, and usually if you for these points you can see we do not have this name attribute anymore, because we actually from this attribute from pieces node we actually want to make sure that we actually copy the attribute. So press that name. So now we have copied this attribute, and also do the same for the copy attribute of the for the shelf itself, like that. So now we have copied, and it's going to recook our copied points intersect because of the change attributes. You can see we have basically got this, and inside here we can now use the you can see that we have we should have our name attribute. See, and we can basically attribute name is going to be a name, like that, and fetch unique values. You can see it should be basically the same, except we can easily read the values of this attribute. So let's say I want to make sure that we have maybe less of the food canned food. You can see we can start deleting those. Another food item, maybe a little bit less, like that. So now we have this. We can now reverse it like that, and obviously you can do whatever the setup you want, whatever you want to do with all of these setups. So let's say I'm happy with this setup, and there's one more thing that I want to show, which is the Y offset. You will notice that there's this weird setup that these some of these assets are actually floating inside this instance point post process, but don't worry, it's actually just inside Houdini. In Unreal it actually looks correct. So let's say I'm happy with this setup. What I'm going to do is, for the demonstration's sake, I'm just going to get this second output as my point cloud. I'm just going to freeze this. I'm just going to go ahead and copy this inside my HDA. I'm just going to so basically this is the HDA that I'm actually sending to the Unreal. I'm just going to connect these points as my output and save the node inside Unreal. Let's go ahead and take a look at the result. So my HDA inside here, copy it. You can see we have basically gotten this setup. You can see it actually looks correct. Any of these boxes that are actually floating inside the inside here, you can see like these two boxes are actually correctly set up inside here. When some of the assets are basically kind of looks like they are not actually sitting on anything is because of the incorrect pivot for the assets inside Unreal. So let me actually go ahead and take this box and let's drag it out inside the game world. So you can see it's pivot. So ideally it should be right at the bottom of it, like that. So for something like maybe this cardboard box, you can see that pivot is right at the bottom of it. And once we have imported it inside Houdini, the pivot is basically going to be at the 0, 0, 0. And this is the ideal pivot for us to start to copy this pivot to the points that we scattered around, because our scattered points are also on the surface of the basically the surface of these geometry inside here. So our pivot should be ideally there. So but sadly not all of the assets are actually kind of correctly set up, the assets you have bought. So one thing you can do is either fix it inside the Unreal, and in Unreal you can go ahead and go to the modeling selection, go ahead and go to the so that's going to be on the transform, and you can see you can actually go ahead and press on the pivot, and you can go ahead and edit the pivot to it. So let's say I want to make sure that my pivot is at the bottom of it. So again, it's not ideal inside Unreal, but let's say this is a better pivot location. You can then just press accept. It's actually going to, you see, it's actually going to be a warning. This will modify the selected static measure assets. So now our pivot is going to be correctly set up. And once you you have to re-export this asset to the back to the FBX files, as we did at the beginning of the tutorial, so that it also gets the correct pivot inside Houdini. So this is one way you can fix the assets that are not correctly pivoted. So that's one thing, but we can actually go ahead and offset our geometry inside the Unreal, inside Houdini itself. In Houdini, to show how it works, I just went ahead and imported only that specific asset, which is this cardboard asset inside here, and you can see that inside this pivot is basically the pivot. Our grid pivot is at the origin, which is basically at the middle of the object. So this is not ideal pivot for us to go ahead and start copy it. So inside this find files in folder, I actually added a specific option for us to actually go ahead and offset y-axis on the grid. So if you press on it, it's going to automatically basically going to put it on the top of our grid on the y-axis, and also going to create an offset attribute name. And this offset attribute name is going to be the name that we are actually going to head and offset these points, this by amount, our points that we are actually going to send to the Unreal. So if we take a look at it, we have offset it. Let's take a look at the points. So this should be y offset. On attribute, you can see we have offset it by 0.07, all of these points, like that. So let's go ahead through these, all of these. So since we have only one geometry, I went ahead and put less of a scatter, like that. And inside this copy to points, let's take a look at it. So the copy to points actually going to work correctly, because our imported geometry is now sitting on top of it, like that. So copy to point looks correct if we merge these together, like that. So so this is not going to look correctly, but this, and let's say this one, this one. You can see these two is actually going to let me look at actually so I guess the very start of it, because we have copied point basically the same thing. You can see now this looks correctly. I want to make sure that this also correctly looks inside Unreal Engine. So the collision is going to be generated properly, and now what we do is go ahead and move our points, offset our points that we actually are outputting from our copied points by the offset y-axis. So you can see that if I select my instance point null node and go inside my copied points, and if I deselect my offset y-axis, you can see that my points are actually go ahead and go back to the incorrect pivot, because we have basically moved pivot on this geometry. We want to make sure that we actually go ahead and move this also on our points. So this is why why this actually exists. So this is going to offset it by the amount that we have stored. So this is going to be also basically not all of the assets are going to have any offset, and that's fine. If the offset is 0, it's just going to add 0 to it, and it's not going to move them. But for the asset that it needs it, we have to make sure that we actually go ahead and offset it back to the basically up on it. So let's say I actually go ahead and turn off this offset and go ahead and merge these together, and so this is going to now, you can see that this looks correctly inside our copied points for the intersect post process. And let's actually look at this. Let's copy this. Let me show you. It's actually going to look incorrectly inside the Unreal Engine. And let me go ahead and check this out. You can see the pivot is now basically the points that we copied basically sits on the shelf itself, and you can see the pivot is inside here and it's incorrect. So that's the reason we want to go ahead and make sure that we actually go ahead and offset the y-axis that we have inside here. Inside here you can see it doesn't look correctly, but that's fine. So maybe I can actually do a little bit modification that it's actually also correct for this instance to point post process also. But for now, just know that we have basically offset them correctly, and we can actually go ahead and delete the offset attribute from these points, because once you have offset it amount, we don't actually need to send the offset information to the Unreal. Let me unfreeze this, take a look at this, freeze it back on, copy, let's paste it back inside these points. Now let's go ahead and rebuild. You can see with the offset we have correctly placed our assets on the shelves of the of this asset. So yeah, so that's one thing for the offset of the geometry. So that's pretty useful thing to know. So that's that. Another topic I want to touch on is actually dividing the work that this copy to point intersect node is going to do into separate work items. So let's say I have these different shelves that I want to go ahead and copy the props to, and I know that basically I know that for each one of these shelves they are actually not going to intersect with each other. So basically anything that happens intersection analysis inside here, I know for sure that not going to be affected by other ones. So this is where the dividing it into the different work items actually going to work out to utilize multiple cores or multiple CPU cores, because inside this copy to point intersect, all of the logic that is actually around inside basically intersectional analysis is actually in a compile block. So if we give it we can basically inside this copy to points we have option for us to split it into the multiple work items. So let's say I do not split it, and let's say I have go to the scatter. Let's say I put it maybe like 20,000 points. So this is a lot of points, and I go ahead and go to my copy to points intersect. It's going to start to it's going to be a pretty long time for us to actually go ahead and get any result from this node. So to speed it up, we can actually go ahead and create a different work items. You can see it's like 1,000 by this, and it's going pretty slow. So I'm going to stop this, and let's actually disable this. Let's go ahead and set this up as a multiple work items. So inside my grid, where I assign for each point my start up and normal, I actually went ahead and gave for every piece also the point, basically a piece attribute, which is going to be its point number. So this piece attribute is going to be copied to basically the piece attribute is going to be preserved to the copy to points like that. So this piece attribute should still be inside here. You see that basically for inside this copy to node, all the points have the same piece attribute, and in this scatter node, and I want to make sure that I actually go ahead and preserve the point attribute of the piece attribute. So inside attribute output, we want to save our point attribute piece. So this will basically make sure that all of these points actually have a piece attribute. Let's say this is a 15. You can see all of the 15 is going to be this piece attribute inside here. And so this means that inside this attribute from pieces, we can basically the piece attribute is going to be come along from here. We still have our piece attribute. Inside this copied points intersect, we can use this point attribute as a splitting into multiple work items as a piece. And now I'm going to enable it. You can see it's going to work now much faster. So you can see, and we are done with it. So you can see we have scattered them correctly. Take a look at it. You can see we have gotten our result very nicely, very fast, by basically dividing it into multiple piece attributes to work on multiple CPU cores. So if you're scattering across the different places that you know that there's not going to be have any intersections, this is definitely a thing that you should use to speed up all of this process. And the export basically the same setup as here. Yeah, so we also want to offset it, merge it. We can then also do basically the intersect analysis. And so you can see now we have a lot more points. And let's actually go ahead and export this. Basically the same setup. So let me copy this here, save it in Unreal Engine, let me go ahead and drag this out. You can see we have basically got our shelves with the intersect with the all of these shelves are filled up. So yeah, so that's dividing into the multiple work items. That's definitely very useful. Another thing worth mentioning is actually the geometry type that we actually going to collision detect. So for the surface, it's basically something that doesn't have any thickness to it. So what I did is actually went ahead and for my collision detection, went ahead and when I blasted it, I just extruded it with basically with no thickness to these polygons like that. So this is going to be considered as a surface, and since my copy to points is basically all of the points that I'm copying to is basically inside here, and let's say one prop actually go ahead and intersects this one, it's going to, I know that it's not going to intersect, I know that my copied props are not going to be like spawned inside here, outside this one. So basically I know that any of the props that I'm going to copy it's going to either intersect with each other or intersect with this wall. So this is one way for us to detect our collisions outside the additional collisions with the instead of the props itself. So this is going to be considered as a surface collision like that. So yeah. Another way is for us to intersect with the airtight geometry. So this setup is a little bit different. It's basically I made a little bit of a different geometry. So what I made is basically the initial airtight geometry, which is this one. Inside here, I basically merged it with the box. And one important thing for this method to work, you want to make sure that there are no intersections with the collision geometry at all with itself. So something like this, where the box is actually intersecting with the other collision geometry, you can put down a boolean and then just union all of these so that inside there's nothing inside here. And you can use multiple pieces, something like this box. So you can see that I merge them together. You can see that this box is actually let's make this box maybe a little bit up like that, so that it doesn't actually intersect with the intersection geometry like that. So this should work fine because there's no intersecting geometry within the intersecting geometry itself. So you take a look at the copied points, and now it's set to the airtight geometry. You can see we have successfully basically avoided the intersections with the collision geometry like that. You can see it's here, and inside there's nothing basically. And I did one test export, something like this. See, it's basically these shelves are empty like that. So this is with the geometry collision. So that's that. Let me actually go ahead and delete all of this, and let's make this back to just a surface. So for the little bit simpler setup like that. So, and there's also for us to intersection analysis, which is just you can use it fast, but a lot of the times actually basically all of these, if we would have like a lesser point count, so let's go to the surface, let's say we have maybe like something like this, and you put it to the fast, you can see it's basically going to delete a couple of these points. Basically anything that is the fast is basically just checking out anything that is actually intersecting with each other and just deleting it. So it's not very efficient way for you to fill up shelves. So that's why you should probably always use the precise one. And let's put this some back to maybe something like 1,000 points like that to fill the shelf. So that's for the copy to points. And I think I have gone through everything inside this copy to points intersect node that you can use. So yeah, so that's that. So this find folder, what else? So for this find folder, so yeah. So one more thing I want to talk about is the extract from. So this string is kind of like it's not a very permanent way to work with data inside Unreal. So what you can do is actually go ahead and create data tables from the inside Unreal Engine and import the data from those. So that's one way we can use this. Another way you can use this find folder. So that's what I want to talk about next. So what else? So there's so yeah, I think I basically talked about everything inside this. So you can basically delete any attributes that comes inside with this geometry. So you can use the set for maybe you need a set file path. So basically you want to know where this file is actually located. You can go ahead and create that attribute on it. So that's going to be primitive. That's going to be a path attribute. You can see. So this is the path of this file inside on your local drive. And you can also expand. So basically, if you're using environment variables, like I do, so you have a cache drive like that, or you can expand it to show the drive like that. So they remove file index. So inside this file, finding file. So basically, there's some way for us to get the data, and this is basically the entire script for you to actually fetch the geometry inside here. And all of the fetch geometry basically goes through the file import node with the compile block. There's we are getting all of these, and then we just process the geometry like that. So that's all of this that is actually happening inside here. Another way for us to store information about the meshes that we want to scatter around inside Unreal, we can actually use data tables. So inside this, inside the Unreal, you can go ahead and create a new structure, and the structure is going to be very simple. It's basically just a one entry for each row, which is going to be our static mesh reference, and the name of it is going to be Unreal Instance, something like this. Our reference to our static meshes like that, and then you can go ahead and create a data table from it like that. So in this data table, what I have is basically a row name and the asset. You can see I have basically collected all of the assets that have a plant on it. So let's say I want to scatter plants on my shelves. So I have a data table that I can go ahead and load inside Houdini without copying the manually paths of these assets. So inside Unreal, so I already did the setup of it. So let's do it again. Find folder inside here. I want to, instead of the extract from string reference, I want to from JSON file. Then I have to give the path to the JSON file. So just going to copy it. So one thing you have to do is now actually go ahead and extract, basically save this. So let's say this data table as a plant. So go ahead and right click on it and export as JSON file. So inside here you can basically save it whatever you want. Just make sure that you know where it is. And once you have saved this JSON file, it's actually a very simple how it looks actually. So let's take a look at actually the file that I just actually saved. This inside here. You can see it's a simple JSON file with the name of it, which is always going to be the basically the name of the row name, which I set up as my which has to be a unique, which is basically the static mesh name of it, and the Unreal Instance, which is the name of the field that we named, which is going to be the path of it inside Unreal path. So this is my exported data table, which we can actually go ahead and import inside Houdini. So inside here, point to the JSON file that I just opened up. So Unreal path is going to be a Unreal Instance like that. The file name is going to be a name. So this is basically always should be the uppercase name. So this is how Unreal actually names every row inside the tables. So that should be name. So the folder path, they want to look for the assets, it's going to be the same one. Unreal asset export like that. FBX, that's fine, and we can go ahead and reload files. You can see we have got our gotten our plants. So there are 12 unique entries. So let's take a look at our data table. You see there's 12 unique entries also. And one more thing to make your life a little bit easier on creating data tables, we can actually go ahead and create these JSON files because it's kind of a long process for us to actually fill up these data tables. So basically, we have to press add, and we have to go ahead and find these assets, and we have to give it a name. So one way we can actually go ahead and create these data tables that we can import inside Unreal, actually inside Houdini. So what I do is created basically there's another HDA, which is basically create a Unreal reference JSON data table. So this is very similar to the copy to get finding files. We want to copy the Unreal references paths. So let's say inside Unreal, I want to, inside this measure, I want to get all of these cylinders. Let's say I want to make props out of them. And let's say I want to make sure that I actually save all of these props, let's say around some corner in my game world. I want to make sure that I have these props saved, so I do not have to manually every time copy these paths. So just copy the reference inside here, go ahead and paste it inside the JSON creation file. Save the JSON file to basically give it a folder where to save it, the name of it, and then the mesh data table variable name, which is the variable name we gave my structure. Let's go to data tables. So the structure of this one, so it's going to, so that Unreal Engine can correctly place our JSON table inside this field. So that should be forever, whatever you're going to use, Unreal instance. Basically, those names should match. So once you have created, so I already created it, I can, and if the file already exists, it's going to actually say that it already exists. So you want to override it. So I'm just going to put override. And once you have overridden, you can actually take a look at it. The JSON file will basically look exactly the same as the one that I exported from the Unreal Engine. And that's good because we can actually go ahead and import this JSON file inside here. So let me import to the game data, welding props, okay. And now it's going to give me option for us to which data table to use. So this is going to be ST actor references, which is the structure I created. Just press apply, and that's it. We should have our welding props. You can see basically we have imported our data table inside here like that. And for the row name, it's very nice because it's actually this JSON file is actually going to automatically give the name of the every row inside the data table as a name of this asset. That it's actually as a name of this asset from the Unreal instance, basically the Unreal path, like that. So yeah, that's one more thing for you to use to make sure that you can save these assets, and then you can just go ahead easily. Let's say I want to now I want to, instead of these props, I want to create my from plant. So I just want to, from JSON file, just going to go to the actually I think I have these in a desktop. That's going to be it plant accept. Inside here I went to Unreal path. It's going to be Unreal instance. As a import, file name is going to be file name key is going to be a name, and you can see it's automatically found them because my folder path is still the same, extensions are still the same. It's just the way that we are getting information. Instead of the copying the strings, we're actually using the JSON file. And one last thing I wanted to touch upon is actually the collision detection method, which basically creates the proxy geometry that we are detecting collisions with. So by default it should be shrink wrapped, and by default I think it should be a 30% reduction of the polygon of the shrink wrap. So if you take a look at and take like an old node out of the third input, it's going to visualize our collision geometry. You can see for every basically input that every file we want to copy around, we are creating a proxy geometry, which is a low geometry, which will make our intersections intersection detection a lot faster. So basically the shrink wrap method is basically the best one to use because it gives good results and pretty fast ones too. But you can use also the bounding box if you have a very simple geometry, which is kind of like the initial geometry that I showed, something like this, where all the objects are pretty much the square. So this is good for something like that. So that's going to basically make it faster too. And the third intersection is actually a grid cutout, and which I'm going to actually show on my second. The grid cutout is actually used for the detection for the table. So where is it? Like this. So basically the computer and all of these were put on manually, but all of these props are actually scattered around randomly with the grid cutout node detection. So let's take a look at it. So I got all the possible props inside here. I went ahead and copied them around here. So this setup is a little bit different. Basically, I imported a table, get the scattering, remeshed it. So because I wanted to point an attribute on it, basically a mask. Let's take a look at the mask. So basically, I thought, let's say, I want my keyboard be here and monitor here and the tower here. So I went ahead and deleted it and scattered across the remaining place like that. And then the rest of the setup is basically the same, but inside here for the detection I actually used the let's actually I have changed inside here. Let's take a look at the grid cutout. So let's put down the grid cutout. Let's wait for it to cook. You can see it's not the fastest one, but it's actually it gives also good results. So let's take a look at the grid cutout. So the flattened axis is Y. It's basically, you can think about it as a basically array that is basically pointing from the y-axis below, and it's going to create the cutout shapes for every one of these props. So you see, this is good because it theoretically gives us option for our props to be very close to each other. So let's say this player could even be very close to something like inside here and all that. So this is a very nice, precise way for us to create collisions like that. So this is the grid cutout, and the axis, as you can control it, and the resolution of it. So 25 looks pretty good. We can take like something like a 10. This will be a 10 by 10 grid. You can see it's less of a geometry, less of a resolution. And for the rest of it, I use the basically the same instance point post process. Let's fetch the values. We can make them at 0, make them more of these. Basically the setup is the same, like that. So yeah. One more thing I want to talk about is the actual geometry that we are getting from the Houdini, and how can we change the way that it is actually created inside Unreal. So by default, anything that you get from the Houdini from those points is going to be hierarchical instant static mesh component. So basically this is by default going to be grouped together. Any of the same geometry that is already basically the same geometry is going to be instanced and grouped together like that. So yeah, so you can move all of them together. And actually there's even option for you to go ahead to the instanced array. You can see all of the members actually inside here. You can actually go ahead and move them, every one of these, around individually. So this is good for the optimization of the rendering. If these props do not have to be like dynamic, and we do not need to simulate any like them falling down. So that's the default one. And any of the geometry that is actually not when there are no multiple of the same geometry, something like we have in this HDA only one shelf, is going to be actually static mesh component. And whenever there are more than one, it's going to be hierarchical instant static mesh component. So, but there is also another way for us to do it, which is basically split every component of our HDA point that we are actually exporting to Unreal into its own static mesh component, like that. And then you can just go ahead and it would be basically the same as me dragging out something like these cylinders geometry outwards and then just operating on them. So you can actually go ahead and bake this result like that. You see we have all of these, and let me move these outwards like that. And you can see it's basically the same. I can go ahead and move them around because all of them are static mesh components, and we can simulate physics on them, which is not possible for these instanced mesh components or these. So yeah, so that's that. And more for you to enable this splitting into its own static mesh components, you can go to the instance point post process, and there's actually going to be option for you instance splitter, split every point into separate actor. If you press it, you can see that there are going to be two new attributes. So by default, it's going to be just a instancer splitter, which is just it has to be a unique attribute value for each one of these points, so that inside Unreal it's actually going to split it together. And the attribute that Unreal is looking for is actually Unreal split attribute. So you see that this attribute, Unreal split attribute, is actually the name of the attribute that every point has its own unique value. So you see mass instance splitter, and this attribute is basically a point number. So this is an easy way for us to split every import of our geometry into its own static mesh component, like that. Another thing that's great about this method is that it's actually independent of the surface that we want to try to copy on. So let's say I have I create this mountain terrain, sort of like this, and I want to copy whatever the props I have around here. It's actually pretty easy for me to basically create a scatter and a line, basically the same setup, and you can see that now these props are basically scattered along the normals of the polygons that I'm scattering across, like that. So yeah, and this also uses the easier bounding box scatter method. You can see I'm getting this kind of result. So it doesn't really have to be on a flat surface like that. So yeah, that's that. And I think I'm going to end this tutorial. I pretty much went through all the features of it. Hope you found something useful. Write me an email if you want some additional features for it. And yeah, see you next time.